All right. Welcome, everyone. Thanks for joining us today. My name is Julia Blaze, and I'm a product management lead here at Chronosphere. Today, I'm joined by Simon Donahue, Senior Sales Engineer at Chronosphere. And our goal today is to give you an inside look at the Chronosphere platform to kind of dive deeper, especially into the world of distributed tracing, and show you how that can benefit your observability teams. Now, as we begin, very brief overview of where we are going. We want to talk to you first about how to use our control plane features, dynamic sampling and control, to actually get the right amount of trace data into your system at the right time. Once we talk you through how our features help you get the right data, Simon's going to talk you through how to use that data to then accomplish some of those other observability goals, like faster troubleshooting and triage of error or latency issues throughout your environment. With that, let's go ahead and get started. All right. So here we are in the Chronosphere platform. And like I said, today, we're going to start our deep dive by a look at our control plane features for trace data. Now, trace data, almost uniquely among all of the data in the observability systems, is extremely high volume. If you've ever worked with tracing data before, you might have seen how you can start to add tracing to a particular service or operational flow and quickly see the volume increase. This is because of the nature of what tracing is, right? Metrics data, they're data points per second. They're sort of small pieces of information that are sent very frequently. Trace data is actually connecting a bunch of different operations together. For each of those operations, you get both the manually added data, like tags on top of these operations that let you know what service, what operation name, maybe what environment, maybe what region, is this US East or US West? And then you get all the information that also connects those individual snippets together in one long flow. That's why these traces can grow to be very large individually over time. Also, trace data, because of how it's set up to track entire flows, is deeply complex and interwoven. It can be really hard to pick out an individual trace or to really understand how and where your costs are coming from. So when we talk about tracing data and control, number one, we want to talk about volume control. But even before we get to volume control, we want to talk about giving our customers a better way to understand their trace data so that they can make good decisions about what volumes are good and helpful and what volumes are maybe less helpful and maybe they don't want to keep those as much. So starting here in our trace control plane. Now I'm in the current month, so I'm in April of 2024. You can see the exact date that we're at. We're on April 15th. Happy Tax Day to all those who celebrate. So as we go through this month, you can start to see how much data we're ingesting and processing and how much trace data we are persisting. Now, if I want to change the volumes coming into either of these places, so increase the process data or increase the persisted data, I'll use some of these different control tools to do that. So if I want to increase or decrease the amount of trace data that you're ingesting and processing, I'll use head sampling. And I want to change the volume of data that you're persisting, I'll use tail sampling. Specifically, though, before I know what head sampling or tail sampling rules to write, or what amount of data I want to increase or decrease, I need to start to break that data apart. Take that big fire hose and start to put it into groups of data that are smaller and that represent units of business value to me, the customer. So you can see in this control plane UI, we have created a bunch of data sets. And these data sets take subsets of trace data, start to track the volume for that subset to help me understand, hey, for these critical teams, for these critical services and checkout flows, how much data do I have in my system today? Do I want to increase or decrease it? You can see that in this hypothetical business, I have an ordering team, I have a payment team, I have a checkout flow. I'm probably an e-commerce business who really cares about making sure that my customers can actually complete their purchases when they're using my website. So as I look at this, I've broken it down. I kind of understand some relative business value. Probably my payments team is more important than my product team. Probably my production services are more important than my staging services. And something I want to dig into is, of course, my production checkout services are probably my most important. That's the checkout flow. That's the thing that my customers use to put money into my system. That's where my revenue comes from. So if I click into this data set, you can kind of see how we've set it up. This is a data set that tracks all traces where the operation is the checkout operation and also where the service name is the portal service. I happen to know that that's where those checkouts start. In fact, you can also see that reflected here that the root service is the portal service. This ensures that I'm getting maximum fidelity for that service and for all of the specific checkout flows that initiate in that service. I can kind of track that volume here. And if I go back a little further, I can see that volume over time. I just want to make sure as I create this data set that I'm getting enough data in the system for me to be able to accomplish my critical triage operations for the portal service and for that checkout operation. Now it looks like I have a pretty good volume of data right now. If I wanted to change the volume of data for this, what I would do is I would go over to my rule pages and I might create a rule that's specific to this data set to make sure that I'm getting the data that I need. I'll go over to our tail sampling rules UI. And as I look down this, I can see that sure enough, I have a sampling rule that's relevant to my portal service. Specifically, the sampling rule keeps portal service traces that query the database a lot. I probably created this because those are some of my critical traces. They touch really important parts of my infrastructure. And if they start failing, I know that my checkout service is likely to fail. So I want to make sure that I'm getting really high fidelity. In fact, that I'm keeping 100% of traces that match that criteria. Now I'm looking at the last hour, but let's say I expand and I look back over the last 12 hours. Sure enough, it looks like I'm capturing this data. Obviously, there's a natural flow as users come in, check out, and then go back to eating lunch or doing their day jobs. But it looks like I'm getting a pretty good flow of data over time. With this in mind, I'm pretty confident that I'm getting the amount of data that I need for my checkout flow and my portal service. Of course, if I have sort of specific budget goals, I can always change my header tail sampling rules for this data set or for any other data sets to make sure that, let's say, I trim some of my fulfillment team data in order to have more data for my portal service checkout. Or maybe I trim my portal service data because I've added a lot of instrumentation and all of a sudden it's more than I need. I can always make those changes. And of course, with Chronosphere, the way that we store your sampling rules and allow you to adjust them dynamically, any change can go out to that service and be updated in 15 to 30 seconds, depending on how you set it up, without requiring you to re-instrument or redeploy any of your services. So we try to keep this really dynamic, something that you can really target, that you can turn up when you're having an event or an incident to get high fidelity data, that you can turn down when the incident is over so that you don't have to pay for that data all month. You only pay for it when you need it. And in this case, we are in our demo environment. I've tuned this data set. I know that I have the data I need. Now that I know that I have the data I need, what do I do with it? And Simon, I'll hand it over to you to showcase what you can do when you're confident that you have the right data in your system.
All right. Thank you, Julia. So now that we're tracking this endpoint and we understand that we have all of the data that we need, whether we should apply sampling strategies or not, we also want to take a look at how the platform can actually troubleshoot this endpoint. So here we have an alert that is configured to actually watch the portal service when the checkout endpoint is having errors occur. This is something that we can track through auto-generated metrics that we generate whenever we ingest traces, or from, say, first-class metrics just coming directly from your application itself. Whenever we create this monitor here, we can also create annotations down at the bottom. And this is rather important because you're never really sure what direction you're going to go whenever it comes to a workflow, or you're triaging something in a certain situation. You might have some context that leads you down one path or the other. But either way, down here, we can dynamically create these links based on, for example, the endpoint that is having errors, or whether you want to go directly into trace data, or perhaps we want to go check out the service, which is what we're going to do here. When we open this up, we're going to come to what we call Chronosphere Lens. This is an auto-generated self-maintaining dashboard where you can pretty much teach the platform how to look at metrics that already exist in your environment and learn from them in a way where they can just provide insights around, say, your services or sets of infrastructure all directly in one screen. So we're able to put all of the compute metrics, the RPC data here for this portal service that we're monitoring and we're responsible for. And indeed, when I scroll down, I see that there are spikes of errors that are kind of going up and down throughout the day. It looks like we have some pretty high latency as well. Coming down further, this also ties into your distributed tracing data and the monitors. So we came from one of these monitors, but coming back to the data here, we're looking at alerts in particular, and we can see that there are some services experiencing errors in a bit of an elevated rate downstream from us. So the auth service and the portal service here are much higher than normal. And this lets us jump off into one of these directions. So it's nice to understand that perhaps we're not alone here, and one of these other services are also having errors at the same exact time. And I can hop off into this service and see what's going on over here as well. And that's part of what Lens or these dashboards here are really meant to provide, is a jumping off point if you spot something, or if you just kind of want like a screenshot of your picture of the world here and the stuff that you care about. We can put it all in one place. Back to our workflow. Again, we see some abnormal spikes here in errors in our P99. And scrolling down further, we can do a similar analysis that we did a second ago, where now we see many more of our neighbors and our dependencies, both upstream, where we came from, the portal service, and the ordering service here, which is now kind of our center of our world. I can see that there are spikes that are causing alerts for the ordering service to fire as well. And again, I see context telling me that there's errors happening elsewhere, right? The notification service, this Octane Pay service or fulfill service, our billing service. So perhaps we'll again, let's dive into one of these and see if the pattern kind of continues, right? And this is what we sort of mean by triage. You're really not sure where this is going to take you in terms of workflow. But at this point, it's pretty safe to say that errors are happening across this entire request. And if that's the case, then maybe we want to look at a few other things here, like events, perhaps. So if I come over to our events, we're looking at events for the billing service in particular. Events that we have, or what we call changes explorers is the page we're looking at, can integrate with a bunch of different sources. So different cloud providers, your GitHub, BuildKite, LaunchDarkly. If you want to see when there's deploys and feature flags and whatnot, actually happening, you can track all of these things. And you can both have them in the Explorer like we see here. And I can note that there does seem to be a deploy that started and stopped, and then some alerts that fired right after. You can also visualize these directly on top of the monitor panel. So when somebody drills in from they get paged, they drill into the monitor, they could see right there that there is a deploy recently. And you can put these over dashboard panels as well. So you can get context from these in a number of different places, depending on how you want to set it up. But now we know that something did change recently. And perhaps this has something to do with what we're seeing. So now that we've sort of investigated things at a bit of a high level, we know that there was a change recently with the billing service. There's alerts that seem to be firing from all of our different dependencies. While we're at the front with the portal service, everybody further downstream is kind of seeing something similar. So let's actually go into our traces here. This will bring us to our trace explorer. And this will bring some context along with us as well. So we can look at the time frame that was selected on the last page on the dashboard. So the last hour worth of time that we're looking at, the fact that we're looking at the billing service. And in our case, we're interested in errors. So we're going to just type in errors, error equals true here. And then anytime the billing service in particular has an error, we will make sure that we're looking at traces where that actually happens. So this is looking at entire traces where the billing service has an error, just for clarity. Scrolling down, we have our statistics and some other sort of analytics that we do. We really intend for this to be both usable by those who might not be familiar with distributed tracing, or what's maybe even the metadata that's inside of their own traces that they use every day, all the way to people who are experts and maybe the architects behind the whole thing. So as an example of this, we are again looking at errors here. And we can see kind of what we already discovered. The billing service and the portal service and the ordering service all seem to have errors. We saw from our topology earlier that there seems to be a lot of services in this path that we're going down, all having errors. And this is somewhat confirming this. If I wanted to, I could even aggregate this data by another dimension. So any of the metadata that is on your spans, you could use this here. In our case, we're going to just look at the operation for a bit more context. And not super helpful, but we do indeed see that our portal service checkout, like we saw originally, and a couple other endpoints are having errors. But again, we don't know which one. So one of the ways that we try to make this easy, and in reference to what I mentioned a second ago, we want anybody to be able to come in and actually derive insights from this. I can use what we call leaf errors. And leaf errors will do analysis for you to look at the data that you're displaying and tell you which one of those endpoints or which one of those services is actually propagating errors elsewhere. So in our case, we saw errors happening in 5 different services, but in reality, the Octane Pay service here is really what's causing them And it seems to be whenever they're authorizing a card payment. So now that we know this, we can include this in our span filter just to make sure that we're only looking at traces when this is actually happening. Now, we saw on the other dashboard as well that our P99 was spiking up as well, right? Again, similar sort of scenario. This isn't really telling us why, but we also have what we call a critical path. And critical path will do something similar to what we just talked about with leaf errors, but for latency. And this will tell us which set of spans is contributing the most to the latency of the entire trace. And in fact, we can see that the Octane paste service here, not just is it having errors, but it's also having high latency, which does kind of track. This can't point to some specific problems. And from this point, I might just want to go and check out the traces where this is true. And what's happening here is we are taking all of what we've input into our filters at the top and displaying only traces where these things hold true, meaning I can just click on our first one here and I can get a full picture of what is actually happening. Again, this is kind of what we expect already. We know that the portal service was having errors because that's why we were paged. As we explored, we saw that the ordering service and the billing service were as well. But now we know that really our Octane paste service is propagating these errors and having everybody else have issues on top of just taking quite a long time to begin with, right? This request, the most of the time we're spending is probably waiting on this payment service to fail. Now, once I get to this point, I might again have kind of a decision to make about, do I want to go look at my logs? Do I want to go look at a dashboard? Maybe I want to go check out the Octane paste service and see what's going on over there. Whatever the case is, using the context we have, we can actually derive links based on the span tags and the details that we have in this span and make it really easy to just point anybody in the next direction they might need to go in. So whether it's a dashboard, whether it's logs, whether it's something within the Chronosphere platform or external at all, we will take all of the different span tags here and turn them into variables so you can easily just have URLs that can link out to whatever your next destination might need to be. Now, from this point, I might also want to track some of this behavior. So I can take all of the context that I've added into our search criteria here and actually track this exact behavior with a metric. So what this will do is create a metric where there's errors that actually get captured, whether they happen or not. But we want there to always be an error with the billing service, and we want there to always be communication to this Octane paste service. I can make this even more specific if I want to say the Octane paste service needs to have an error as well. But kind of the point of this is I want to track this type of behavior because it was an issue recently. And then whenever I'm done with it, I can actually just turn this off again. I can just get rid of this metric. So I'm not paying for it or storing it when I don't need it, but I am able to put it on a dashboard or in an alert and understand that behavior until I'm ready to kind of let it go and things seem to be settled down. And with that, that concludes the demo. And just to kind of go through again and reiterate what we talked about, we went from coming from a monitor where we were monitoring a specific endpoint having errors. We went through and looked at our neighbors both up and downstream from us, all of our dependencies, and we were able to see that others were also having errors. We're not alone here. And then once we got into our traces, we were actually able to quickly figure out which one of those services was the culprit and then track that behavior from now on until we're settled and maybe we added a fix to the sprint and we're good to go. So with that, I'll hand it back to you, Julia, and we can close out.
Thanks so much, Simon. Really appreciate you walking everyone through that today. Also, thank you everyone for tuning in to today's demo. In addition to the recording of this demo, we'll also be sending you an email with some additional resources. In the meantime, if you do have any questions, please contact us at webinars@chronosphere.io or visit chronosphere.io to learn more. We really appreciate you taking the time. Have a good day.